By the end of this video, we'll have created a working Sawblade trap that causes the player to get knocked back and a little bit damaged whenever they collide with it. Let's get started. By viewer request, we're going to be creating several of the traps found in this Pixel Adventure 1 pack. These are traps that come with the pack, so there's quite a few of them in here, different things you could do, different effects we can add. If you don't have this Pixel Adventure 1 pack, you can find it in the video description. And I'm going to pick the saw as the first trap that we're going to create, simply because the functionality of it is quite similar to the enemy that we already have, so there isn't too much work to do in order to set it up. To get it started, let's take this multiple saw blade animation, the one that says on, and just drag this whole thing into the scene, and that's going to ask us to create our animation. I'm going to go back up to my assets folder, go into animations, go here and create a new folder called saw, and I'm going to rename this from new animation to saw idle. We only need it to have one state because it's only going to just be forever spinning. I'm going to rename it to saw in the hierarchy, and in order so it displays, I'm going to change its sorting layer from default to game and change it to maybe order in layer 4. We can just see how that interacts with the fruits and other things. If we want it to appear on top, then 4 looks good. Maybe we want it to appear under the fruit, so we could also just lower it maybe to 2. Yeah, maybe that makes more sense. It's also quite small, so we can see this is a 38 by 38 sprite. So I'm just going to change the pixels per unit to 38 and hit apply, and that's going to make the saw a decent size. If we hit play, we can see that the animation is already in place and it's working, but of course if we run up to it, our player just walks right through it, so that's not great. In my scripts folder, I'm going to right click and go ahead and make a new folder. We're going to call this traps, and then inside of it, we're going to go here, go create a new C# script and name it saw, and then once it's compiled, of course, we'll attach it to our saw game object before we forget. We've already written most of the logic we're going to need for the saw in the enemy script from a previous video, and if you weren't following along from before, I'll link to this video in the description, or you can just copy the code that I have here on the screen. But I'm going to go into the enemy script, and I'm just going to basically copy everything over that we have into the saw script, hit paste, and then delete the bits that we don't need. The saw is going to be a static object. It's never going to move. It's never going to knock back itself. So we can remove all the references to this. We don't need any destroy particles because the saw is never going to be destroyed. It's not going to die, so we can get rid of that die method. And we can get rid of this line of code over here, leaving us with just hit player and get direction. Also going to remove these empty namespaces because we're not using them. If you think it's a bit redundant that we have some very similar code in here in saw as we do in the enemy script, that is that you're all thinking along the correct lines, but we'll be tackling that in the next video. For now, we can go over to this player collision script. Again, I'm going to delete these empty namespaces. We're not using them. And now we're going to scroll down to our on trigger enter and on collision enter 2D methods. And just as a reminder, this script, player collisions, is attached to our player. Because we don't need any any physics essentially with our saw, I'm going to use on trigger enter 2D to handle our saw collisions. So I'm going to add here else if other.compare tag, and we haven't set up a tag for the saw yet, but I'm just going to write saw for now, and we'll set that up later. And we're going to say other.getComponent saw, and then we're going to say hit player, and we're going to pass through the transform because that is what our saw object is looking for. If we go here, when we call hit player, it's looking for the player's transform, so we need to pass that through. Press Ctrl KF to format my code, save, and that should be pretty much all we need to do in terms of setting this up. Like I said, it's mostly copy paste work at this. Back in Unity on the saw game object, we'll need to add a circle collider 2D, and we're going to check the is trigger box because we're using the on trigger enter 2D method. Over here under tag, we'll also need to set up a saw tag. I've already done that, but if you don't have this here, you can click add tag, click the little plus button, and then add the new tag, which is going to be saw. Once you create the tag, you have to remember to go back to the saw object and assign it. And then from there, we can pretty much go ahead and give this a test and see how it works. Here we are, gonna jump on my enemy's head, gonna hit the saw, and just like that, it's knocking my player back. we're creating an obstacle. It's just in the way. I have to dodge it. You know, there's no real way to get around it. It's just a little bit annoying. Just for some cleanup here, we can go ahead and go into our prefabs folder, make a new folder, and we'll call it traps, and then we'll drag the saw in and we'll turn it into a prefab so we can reuse it and place it elsewhere in our level. You may also want to adjust the knockback to player values and the damage values that we set up previously. And again, if you're just joining on this video, we've handled dealing damage in a previous video. We've handled the enemy setup in a previous video. So I'll link to those relevant videos in the video description so you can see how we're handling those bits of the code. In the next video, we'll be looking at how we can clean up our saw and enemy code, which has a lot of duplicate code in it right now, through the use of inheritance in our coding practices. This will also make coding future traps much more efficient, as we're likely to have some similar logic going forward. See you there.